This problem takes us into differential equations. We want to set up and solve the differential equation that will give us the amount of salt in this tank at time t. This tank initially contains 50 pounds of salt dissolved in 400 gallons of water. Brine with a concentration of 1/2 pounds per gallon enters at the tank at a rate of 6 gallons per minute. The solution is kept well mixed and drains out of the tank at a rate of 8 gallons per minute. Find an expression for the amount of salt Y in the tank at time t. And so when we want to solve this differential equation, we want to start by defining our variables. T equals time measured in minutes, and Y equals pounds of salt in the tank. Next thing we want to do is define our differential equation. First, I start describing in words because, so I'm saying, oh, this is the change in salt over time. And so the salt is changing in two different ways. There's salt being pumped in, and there's salt being taken out. The salt in we can find by multiplying the volume in times the concentration in. And the salt out we can measure the same way. Volume out times concentration out. 3 of these values were given to us in the problem. Okay. First 3 of them were the volume in is given as 6 gallons per minute. Concentration in is given as 1/2. Volume out is given as 8 gallons per minute. And then the concentration out is not given. And that's because it keeps on changing. You should expect that because it would be weird if our differential equation only was dependent on constants. And so we need to go up and figure out what our concentration out is. So our concentration out, well, that's the concentration of everything that's in the system. And everything that's in the system is the amount of salt over the total volume. The amount of salt is just Y. The total volume started at 400 gallons per minute. But every minute, 6 gallons comes in and 8 gallons goes out. And so after 1 minute, there's only 398 gallons. After 2 minutes, only 396. After t minutes, there's only 400 minus 2t gallons in the system. And so our differential equation becomes 8 times y over 400 minus 2t. Let's simplify this differential equation to make it a little bit easier. dy dt, 6 times 1/2 is 3, and looks like the 8 would reduce, so I get 4 over 200 minus t times y. Now this problem didn't just ask us to set up the differential equation, it also asked us, it actually asked us to solve it, to find it. So we need to solve and find it. I'm going to need a little bit more room, so I'm going to shrink this down. And I look at this differential equation, I say, well, if I actually, first thing I think is when I look at this, I say, if I solve this, I'm not going to find the solution. I'm going to find a whole bunch of solutions because I'm just going to find the general solution. So the other thing I need is I need an initial value. And so I need to figure out what time do I know some of the salt in there and That is at time 0. At time 0, there is 50 pounds of salt. Now I have my differential equation to solve. I look at it and say, ooh, it's not separable. I cannot separate that. But the good news is, since there's only a single y involved, I can write it as a linear differential equation. Remember, a linear differential equation is one that you can write in the form dy dx plus p of x y equals q of x. And so I write this in that form, dy dx plus 4 over 200 minus t y equals 3. And I remember, to solve a linear differential equation, I need to find the integrating factor. And the integrating factor, I know, is e to the integral of p of x, which in this case is p of t, dt. And so my integrating factor for this problem becomes e to the integral of 4 over 200 minus t dt equals e to the 4, and I look at this and say, oh, the derivative of the bottom is minus 1. The top's exactly minus 4 times minus 1. And so that's minus 4 log of the bottom. Since we're looking for an integrating factor, we don't need the plus c or the absolute values on the log. We're not looking for every possible integrating factor, just one that will work in our domain. And so this is what we need. We can rewrite this as e to the log of 200 minus t to the minus 4th power. And then the e and the log cancel each other out, and we're just left with 200 minus t to the minus 4th power. I'm going to multiply through my differential equation by that integrating factor. So I get 200 minus t to the minus 4th power dy dt. That was a typo in my last line, dy dt. Plus 4 200 minus t to the minus 4th power divided by 200 minus t is 200 minus t to the minus 5th power. Y equals 3 times 200 minus t to the minus 4th power. Now, the whole point of putting it in linear form and multiplying through by the integrating factor is that if we did this properly, the left side always, always, always becomes the derivative of the integrating factor times y. So I didn't do anything in this line. Notice the left side, the right side stays exactly the same. I just wrote the left side in a slightly more compact form. At this point, you can check to see that you've done everything correctly so far, because if that product rule on the left side isn't the same as the line above, then you've either not put it in linear form correctly or you didn't find your integrating factor correctly. So check. First times the derivative of the second plus second times the derivative of the first. And so the derivative of 200 minus t to the minus 4th is minus 200 minus t to the minus 5th times minus 1. So that's plus 4 times 200 minus t to the minus 5th power. And so sure enough, this product rule really expands out to that product. Now we can just take the antiderivative of both sides. Antiderivative of a derivative is just the expression itself, 200 minus t to the minus 4th, y equals the integral of 3 times 200 minus t to the minus 4th power dt. one higher power than minus 4 is minus 3. So we have to take that 3 and divide it by minus 3, divided by the new power, and don't forget the chain rule involved as well. So we have to divide it by minus 1 as well, plus c. We have two last things to do. One is to solve for y. Y equals, we're going to solve for y by dividing through by the integrating factor, which is the same as multiplying by 200 minus t to the positive fourth power. And so I get 200 minus t to the minus third times 200 minus t to the fourth is just 200 minus t to the first power plus c times 200 minus t to the fourth power. Last thing we have to do is use our initial value to solve for c. Y of 0 equals 200 minus 0 plus c times 200 minus 0 to the fourth power equals 50. And so I get c equals minus 150 divided by 200 to the fourth power. And so my final answer is y equals 200 minus t minus 150 over 200 to the fourth power times 200 minus t to the fourth power. Thank you very much. See you in the next section.